Imagine having a superpower that lets you see back in time, peering into the distant past to witness the birth of stars and galaxies. For centuries, humans have looked up at the night sky, wondering about the origins of the universe and our place within it. Now, with the help of cutting-edge technology, we can look all the way to the beginning of the universe, seeing light that has traveled for billions of years to reach us. That's what the James Webb Space Telescope, or JWST, does. Launched in 2021, after decades of planning and international collaboration, it's the most powerful space telescope ever built, representing a giant leap forward in our ability to explore the cosmos. Floating 1,000,000 miles from Earth at a special point in space called L2, JWST is designed to uncover how stars and galaxies form, to search for the building blocks of life on distant worlds, and to answer some of the biggest questions in astronomy. Unlike Hubble, which sees mostly visible light, JWST sees in infrared, allowing it to peer through thick clouds of cosmic dust and gas to reveal hidden stars, planetary systems, and the earliest galaxies that formed after the Big Bang. Its massive gold-coated mirror, over 6 meters wide, and its tennis court-sized sunshield keep it incredibly cold and sensitive, enabling it to capture breathtaking images and data that were once impossible to obtain. JWST isn't just about pretty pictures. It's about pushing the boundaries of human knowledge, answering age-old questions, and inspiring new generations of explorers, scientists, and dreamers around the world. Every observation has the potential to change our understanding of the universe, to reveal new mysteries, and to help us better understand our own origins and our place in the vast cosmic story. On the chilly evening of December 27, 2024, a team of dedicated astronomers peered through their telescopes and noticed a faint moving speck in the vast darkness. A new asteroid, soon to be named 2024 YR4. The discovery was subtle, almost easy to miss, but their keen eyes and advanced equipment caught the telltale motion against the backdrop of distant stars. At first, it seemed like just another near-Earth asteroid among thousands catalogued each year. But as scientists began to analyze its movement and track its path across the sky, a sense of unease started to grow within the astronomical community. Detailed calculations soon revealed that YR4 would pass uncomfortably close to the Earth-Moon system in the near future. There was a small, but very real chance of impact, enough to warrant immediate attention and concern. This new information elevated YR4 to a top priority object for planetary defense experts worldwide. Suddenly, scientists from different countries were working together, sharing data and strategies to better understand the threat. Early estimates put its size somewhere between 40 and 90 meters across, large enough to cause anything from local devastation to a significant regional impact event if it were to strike Earth. The uncertainty about its true dimensions only added to the tension. The lack of precise data about both its size and trajectory made it impossible to predict the potential effects with confidence, fueling anxiety among scientists and the public alike. Every new observation brought hope for clarity, but also the possibility of more alarming news. The discovery of YR4 served as a stark reminder that our solar system is not a static or entirely safe place. It is dynamic, ever-changing, and sometimes dangerous, with countless objects silently orbiting the sun. Finding and tracking these potentially hazardous objects before they find us is the very core of planetary defense. It's a race against time and uncertainty, requiring vigilance, technology, and international cooperation. With YR4, astronomers faced a real-world test of our ability to detect, assess, and respond to a potential cosmic threat. The clock was ticking, and the world was watching, hoping for answers and for safety. The worry about 2024 YR4 was simple, but deeply unsettling for scientists around the world. Its orbit didn't just come close to Earth's, it actually crossed our planet's path around the sun, putting us directly in the line of potential danger. This created a real, if small, chance of a collision in December 2032, a date that quickly became etched in the minds of astronomers and risk analysts alike. At the time of its discovery, 2024 YR4 was labeled the riskiest asteroid ever detected, even surpassing the infamous Apophis, which had once dominated headlines for its own close approach. The margin for error was razor-thin, Even the smallest inaccuracies in its observed position could mean the difference between a harmless flyby and a catastrophic impact. So scientists raced against time to refine its orbit with every observation they could gather. The asteroid's estimated size, around 60 meters across, meant it was large enough to cause devastating regional damage if it struck, far worse than the Chelyabinsk event in 2013, which shattered windows and injured over 1,000 people. The potential impact would release energy equivalent to several nuclear bombs, enough to flatten a city and cause widespread destruction over a vast area. Making matters worse, the window to observe YR4 was incredibly short. After early 2025, it would become too faint to track for years, vanishing into the darkness of space. Missing this critical window meant waiting until 2028 for another chance to observe it. An unthinkable delay when the safety of the planet was on the line. Scientists knew they had to act fast, using every available telescope and the most advanced technology to gather as much data as possible before the opportunity slipped away. The race was on to solve the puzzle of 2024 YR4, with teams working around the clock, sharing information, and double-checking every calculation. As the world watched, astronomers mobilized on a global scale, united by a single goal: to protect Earth from a potential disaster. With time running out, scientists turned to the James Webb Space Telescope for help. Using its director's discretionary time, JWST focused on the tiny, fast-moving YR4 in March 2025, a landmark moment for planetary defense. Astronomers used JWST's mid-infrared instrument to measure the asteroid's heat and its near-infrared camera to gauge reflected sunlight. Combining these, they precisely determined YR4's size, about 60 meters, the height of a 15-story building. This was the smallest object ever directly measured by JWST, proving its value for characterizing hazardous asteroids. Knowing the exact size allowed scientists to model potential impact scenarios and inform emergency planning. JWST's success showed we have the technology to quickly learn what we need to protect our planet. The mission was a breakthrough for planetary defense. The world now had a much clearer picture of the threat. JWST's data revealed YR4 was no ordinary space rock. Its rapid spin and unusual thermal properties suggested a surface almost completely bare of dust, unlike most asteroids, which are covered in fine regolith. Instead, YR4's surface is dominated by large rocks and boulders, likely due to its fast rotation flinging away smaller particles. This rubble pile structure challenges our assumptions about small asteroids. Understanding its surface is crucial for any future deflection mission. Pushing against solid rock is very different from loose gravel. The discovery highlights the diversity of asteroids and the need to study each one individually. Thanks to JWST, we now know YR4 is a unique cosmic oddity. This knowledge is vital for future planetary defense strategies. Every asteroid is different, and surprises like this can change how we prepare. YR4's secrets are now part of our planetary defense playbook. With precise size and trajectory data, scientists combined all observations and ran advanced computer models. In February 2025, NASA announced the best news: YR4's chance of hitting Earth was now effectively zero. The asteroid would pass safely by, missing our planet entirely. The riskiest asteroid ever detected was no longer a threat. This was a major victory for planetary defense and a testament to global scientific collaboration. The process, find, track, assess, and rule out, worked exactly as intended. But the story wasn't over. YR4's path would take it close to the Moon, raising new questions. The focus shifted from Earth to our lunar neighbor. The cosmic drama continued. With Earth safe, attention turned to the Moon. YR4's path would bring it extremely close, with a small chance of impact. In May 2025, JWST made final observations, refining the asteroid's orbit with unprecedented accuracy. The new data increased the estimated chance of a lunar impact to 4.3%. NASA reassured the public, even if YR4 hit the Moon, it posed no danger to Earth. An impact would create a new lunar crater, not alter the Moon's orbit or threaten us. For scientists, this would be a rare opportunity to study an impact event in real time. On June 5, 2025, NASA announced the updated odds and concluded the observation campaign. YR4 faded from view, not to return until 2028. Astronomers will be ready, armed with new knowledge. The wait for its return has begun. The story of YR4 is a testament to global teamwork. From discovery to detailed study, astronomers worldwide shared data and coordinated efforts. The request to use JWST was a collaborative push, led by Dr. Andy Rivkin and partners from NASA, ESA, and beyond. Agencies had the foresight to reserve time for urgent, unplanned events, showing flexibility and readiness. This rapid, coordinated response turned a potential crisis into a scientific triumph. No single person or country could have done it alone. It took hundreds working together. The successful characterization of YR4 proved the power of international collaboration. Together, we turned a moment of fear into a victory for planetary defense. The YR4 campaign was more than reassurance. It was a real-world test that strengthened our planetary defense. Using JWST to precisely measure a hazardous asteroid proved we have powerful new tools. The techniques developed will now be standard for future threats. This experience highlights the need for advanced technology and international cooperation. Surprises like YR4's rocky surface show why detailed study matters for any deflection mission. The more eyes on the sky, the safer we are. Thanks to science, technology, and teamwork, we're no longer passive in the face of cosmic threats. The universe is a little less unknown, and our future a little safer.